Welcome to springlib.
And this problem is the same as the previous problem, so I won't go through much of the detail. You can watch the video for that problem. We've changed the angular velocity to 3.38 radians per second, and now we have an angular acceleration of minus 5.07 radians per second squared. So our position vectors are still the same. We're still interested. It's rotating about an axis that goes from the origin to A, and we're interested in velocities and accelerations at point B. So again, we need to make a unit vector, and I should mention here that I use hats instead of arrows for unit vectors. That's just kind of my notation. That it's pretty standard notation for unit vectors. I just put a hat. It's kind of like it's normalized. So we have the same unit vector here. So the angular velocity vector is just the angular velocity times that unit vector in that direction. The angular acceleration vector is just the angular acceleration in that direction. So we can, calculate those. Again, they're a little different than before because we have a different, the angular velocity is different, and now we have obviously this isn't going to be 0 anymore. Now, again, the velocity at point B is the angular velocity vector crossed with the position from the origin to point B, and we can go through this cross product, and we can see that we get this value here, and in fact, you can see that it's basically half of what we got over here because this angular velocity here was half. Now the angular acceleration is a bit different because now we have to do this cross product and this cross product and then add those two vectors up. And when we do that, we get this value here. Again, it makes some sense. If you think about it, it makes some sense about, if you think about the centrifugal accelerations, how they would be. But again, it's hard to get an intuition about these values. They seem reasonably in magnitude. Again, they're not, kind of excessively huge or anything, or excessively small. So again, it's good to kind of just say, okay, well, they look about right, and their signs you could justify it. Okay, so again, being able to justify your answer a little bit, think about it, is a good thing to do when you get the final result.